Welcome everyone to the last part of our lessons on bivariate statistics. Today what we're going to do is we're going to review the association between numerical variables. We are going to go over the Pearson product correlation coefficient, line of best fit by eye, the least square regression line, and then finish off with Spearman's rank correlation coefficient. All right, by the end of this lesson, over the next couple days, you will hopefully be experts on all types of bivariate statistics. Right? First, in a couple lessons, bivariate obviously means two variables. All right, so number one, for each scatter diagram, describe the relationship between the variables. Consider the direction, linearity, strength relationship, as well as the presence of any outliers. All right, so you're going to list 1, 2, 3, 4 things for each one of these. Remember, direction is positive or negative, positive up, negative down. Linearity, linear, non-linear. Strength, you can be very weak, strong, very strong, perfect. All right, outliers, those are the points that don't make any sense. So, without any numbers to do this with, we're just using our eye. Draw a line through here and I go, okay, let me see. What do you think? Well, first off, I'm going to say that's a strong relationship. Seems pretty strong because the stronger the points are, the closer it is to the line. I'm going to say it's positive because the graph is increasing from the left to the right. It's going up. What do you think? Linear? I'm going to say that's a linear line. Looks pretty linear to me. And are there any outliers? No outliers. All right. So do B and C. All right, B. What do you say with B? No outliers. So let's see. Strong, weak. Let's draw a line through it, or something like this. All right. So it's not terrible. I'm gonna say moderate, maybe weak, moderate. Only reason I'll go with a little weaker is because these are pretty far away from this line. Even though they're kind of grouped here, it's kind of like a cluster. All right. Positive or negative? That is indeed a negative. Linear? Yeah, I guess that's linear. I don't see any curves, do you? You can obviously do regression lines to figure that out specifically, but we're just hanging in there for now. And is there any outliers? There is one. Right there. Right. Problem C. All right. Draw our line, and we're just dealing with that. So, oh, wait a second. That's not a line, is it? What do you think, though? Strength. Pretty strong, because these are quite tightly grouped together. All right. Direction is negative. It does go down, right? Is it linear? No, that's not linear. That's definitely a non-linear. And then finally, there are no outliers. Oops, go back there. Why'd you come off? And there are no outliers. Right? Number one's an easy one. So just get a couple more. All right, number two. Carrie wants to investigate the relationship between her water bill and the electricity bill in her neighborhood. Do you think the correlation between the variables is likely to be positive or negative? Explain your answer. All right? We already learned all these lessons, so all you're really doing here is telling me your answers. I'm delaying a little bit to give you some time, cleaning this board up a little bit more, and then we'll get into it. There we go, that looks nicer. There's a couple marks on here that bother me. All right, so first one. Positive or negative? You should say it is positive. Explain. Well, pretty much a household with a high water bill is likely to have a high electricity bill as well, and vice versa. So the more electricity you spend, makes sense that you would use more water. Probably because either there's more people in the house or you're just using the house more. Is this a casual relationship? Ooh, we haven't used this for a while. What do you think? Yeah, no. All right. The reason you would have a higher water bill is more people using water more the reason you would have a higher electricity bill is more people would be using more electricity. So what I would say is the water bill and electricity bill are causal relationship with the number of people, which just so happens to be with each other. All right? Both variables mainly depend on, oh, there we go, the number of occupants in each house. There we go. Number 3, the table shows the ticket and beverage sales each day for a 12-day music festival. All right? Draw a scatter diagram. You guys are doing your scatter diagram. All right, should be done. You guys can draw scatters. This is your scatter diagram right here. X value, Y value, 25 over 9 up, 22 over 7 up, blah, 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 blah. Calculate Pearson's product movement coefficient for this data. So what you're going to do is, let me go show you on your calculator in case you forgot. Here's my handy dandy calculator that I'm going to be using for everything. All right, so first thing I'm going to do is I'm going to hit second, mem. I go down to number 4 and I clear all my lists to make sure my calculator is nice and clean. I hit mode and I make sure that the stat diagnostic is on. All right, and then I go to stat edit and I'm going to type all the stuff in for L1 and L2. All right, so 25. You guys can do this as I'm doing this. You should do it a lot faster than me because I am holding this in front of here, looking through a video and looking at all this stuff together. No way I get these answers, all these numbers in here right. 23, 29, 28. So I got my first column done. Press to the right. 25, good. I'm gonna do my second column. 9, 7, 4, 8, 3, 4, 8, 10, 7, 7, 9. Told you. Knew I missed one. All right, so you should have all of your numbers nice and typed in, right? Pearson's product movement is stat calc for linreg. R equals 0.7591. R, not R squared. All right, my regression line, I can use the A and the B to find that, and we'll do that later on. Zoom in. And 0.776 is my RP. Right. Now, found a regression coefficient. All right, our Pearson's product moment. I don't know why I say movement. There's no V in it. Now what we're going to do is we're going to find the Spearman rank correlation coefficient, and to do this we are going to rank everything. Remember, we just did this last lesson. So what I want to do is find the ranks for each variable and draw it on the scatter diagram. So once again, number 1 is the lowest number. The lowest number here happens to be 17. So, ready? You can do this with me or do this on your own. I gave you, like, hypothetically, gave you 2 minutes. So, lowest number is 12, so that's 1. 2, 3, 4, 5. Oh, shoot. 4 is 18, 5 is 19. Didn't see the 18. 6, 7, 8, 9, 10, 11, 12. Boom. Beverage sales. 1. Uh-oh. There's 2 4s. Since there's 2 4s, this is 2 and 3, 2 and 3. 2 plus 3 is 5 divided by 2. Both of the 4s are 2.5. All right? Because remember what we said? This is technically ranked 2, 3. 2 and 3. So you take the average of 2 and 3, which is 2.5. All right, so now we're up to 4. 4, uh-oh. This would be 4. This would be 4. This would be 4. So technically these are 4, 5, and 6. These are each 3. So 4 plus 5 plus 6 divided by 3 is 5. All right? So 5, 5, and 5. All right, so now we're up to 7. 7, 7, 7. There's 3 of them, so 7, 8, and 9. 7 plus 8 plus 9 divided by 3. I got to get my average numbers better. Is 8. So this would be 8, 8, and 8. All right, and then this is 10 and 11 because there's 2 9s. So 10 plus 11 divided by 2 is 10.5, 10.5. And then finally, this one is 12. Uh-oh. Mix it up. All right. So I want you guys to plot them right now. All right. When you plot them, you should get something that looks like that. All right. And what's that? 612. Oh yeah, 612. 6 over 12. All right. So they're plotted correctly. Calculate Spearman's rank correlation coefficient. So now you're typing this stuff into your calculator, which I lost. So go to my calculator. I'll type in the numbers with you. So once again, you're going to clear your memory. Second mem, clear all the lists. Always clear the lists. List 1. I'm just going to do this. Type this down here. It's a lot easier. 10. So when you're typing it in, you're just typing in into your calculator this column and this column, or those rows, sorry. So 10, 7, 2, 5, 1, 3, 9, 6, 4, 8, 12, 11. And then the next one, make sure you go up and get that 10 there. 10.5, 5, 2.5, 8, 1, 2.5, 8, 12, 5, 5, 10.5, and 8. Something pertaining to, this is what kind of it looks like. That's the tail end of it. Stat calc for, boom, 0.744. Ew. That's not a very good one. Not a very good one at all. So, 0.744. Perfect. So describe the correlation between the two.
We just look at I put your name down and I'll just submit it to them like around 350, 355.
Perfect. Look at that. Describe the correlation between the ticket sales and the beverage sales. Moderate, because it's in the 0.74 area. It's positive, and it is going up, and it is linear. That's it. Got it? Made a couple of mistakes on this thing, but for the most part, it's pretty good. Rank, rank, rank. See? All we did was we took all the stuff we learned and we put it into one problem. Told you guys would become good at this. Problem 4, we're going to do this again. We're going to take all the lessons and put it into one problem. We just built up, built up, built up. A garden center has a manager believes that during March, the number of customers is related to the temperature at noon over a fortnight. The number of customers and their noon temperature were recorded. There you go. Draw the scatter diagram. If you want to cheat, you can type diagram into your calculator and just apply it that way and transpose it. But scatter diagram looks something like this. You do this, the reason you're doing these scatter diagrams is you're searching for outliers, you're searching for linearity, you're searching to see if there's curves in it. The pictures show you this stuff. Alright, so we got all our stuff up there, right? So I get my calculator, which is next to my phone, which is my camera. All right, so type this all, stat, edit. So 23, 25, 28, 30, 39, 27, 25, 28, 32, 31, 33, 29, 37. Woohoo! First column done. Second column, 57, 64, 62, 75, 69, 58, 61, 78, 80, 35, 84, 73, 76. Should have something that looks like a bunch of numbers. Pearson's product really blah blah blah, the coefficient. Ready? Stat. Calc. 4. Ew, that can't be right. 0.247. Let's see. Let's see if that's right. 0.314. It's still pretty crummy, but how did I mess this up? Did I type in the wrong thing? Told you, it's just a matter of time. 27, 25, 28, 32, 31, 33, 29, 27. That's good. 57, 64, 62, 65, 58, 61, 78, 80, 35, 84, 73, 76. You know what had to happen? What has to have happened is the numbers on the board have to be a mistake. So, as you guys are ranking those right now, I'm going to figure out what the heck went wrong. Number 4. 28, 30, 30. Aha! Should be a 30. And I bet that fixes everything. In your packet, it will be listed as a 30. Because I am going to change this right now. Stat. Calc. Rank. Typo by me. And it was on the problem. So 0.313. Perfect. 314. Now, we're going to do the rank correlation coefficient. I told you guys to rank these. You might have to re-rank the top ones. But you had this in your book anyway. So let's look at the ranking here. 23 seems to be the lowest number. So 1, 2, 3. So this is, there's 2 25s, right? So we're going to call them both what? 2.5 and 2.5. So 25, after 25 comes 27. So this was 2, 3. 27 is 4. Up, there's 2 of them though. They're 4 and 5, so we'll call them 4.5, 4.5. So that's 4, 5. This is 6 and 7 because there's 2 of them. So 6.5, 6.5, 6 plus 7 divided by 2 is 6.5. All right. 7, 8.5, 8, 9. 8.5, 8.5. 9, 10, 11, 12. All right, so we had some data that overlapped. Let's look at this one, the number of customers. Let me make sure you're not blurred. Good. Lowest number of customers. I gotta stand back sometimes when I do this because I can't see. 35, there's 1. 2, 58's 3, 4, 5, 6, right? All right. 7, 8, 9, 10, 11, and 12. Look at that, we did it. Ranked it. Yes, I could have gave you more space to do that, but guess what? I didn't. I didn't have enough space to do it anyway. Plenty of space in your papers. Stat, edit. Let me go get my ranks in here. 1, you're putting them in your calculator to calculate these coefficient. Oh, before we do that, all right, don't do it yet. Before we put it in, keep this right here. Identify the outlier. I should have done this first, just to save time, because you don't want to type it in, erase it, and then retype it in. So we have our original list. Our outlier, I'll just tell you what the RS is. Our outlier is down here. So what I want to do is I want to remove that outlier from here and then recalculate. So since our outlier is this point, which is about 3135, okay, I'm going to take that out and then I'm going to recalculate my RP. All right, now the way this works is 3135 is, all right, so what I did was, we'll get back to this in a second. I found my outlier here and I go, okay, 31 over, 35 up. I'm going to erase this from my list. Now the way I do that is, this is just to do the Pearson first. I'm going to go here and I said, okay, 3135. Just because I don't feel like typing everything in. Go to 31, hit delete, not clear. Go to 35, hit the delete button. All right, and then I recalculate. So I go stat, calc, then reg, calculate, and then I get my RP jumps up to 0.80. Okay, so that's pretty good. Get in there. All right, so now my RP is 0.80. So look how much it jumps up just by taking out the outlier. All right, so I found it before and after the outlier. What I'm going to do now is I'm going to do my ranks. And the only reason I did this twice was all right, D, C. It's stupid that they make you do it twice, because then you have to keep on typing the calculator. Because now I could do my new list on my calculator. So when I go to my new list, edit, my L1s are going to be 1, 2.5. This way I don't have to type the whole thing in again. 6.5, 8.5, 8.5, 4.5, 2.5, 6.5, 11. I'm still going to use that 10, 12, 7, 4.5. All right, go over to my L2s. 2, 6, 5, 9, 7, 3, 4, 11, 12, 1. Wait a second. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, there's 13. Forgot. Wait a second. If there's 13, 1, 2, 3, 4, 5, 6, 7. I just messed everything up. 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How come I can't count? You guys gotta help me out. Let's see where I messed the top up. You see it? Good. 1, 2, 3, 4, 5, 6, 7, Ah, 2 7s. 8, this is 9, 10. This is 9.5, 9.5, 9, 10. And this is 11, 12, 13. Mr. Valentino counted wrong and he messed up all his answers because of it. 1.5, 2.5, 8.5s get changed to 9.5s. Alright. 4.5 stays, 2.5 stays, 11 becomes 12, 11, 13, 8, and 4.5. Awesome. Alright. See, even I make mistakes. I could edit that out, but I like to leave it in to show you that even your teacher can make a mistake. And it takes about 4 hours to edit one of these things. Alright, ready? Step, calc. That's no bueno. Stat edit. I just hacked up this whole entire lesson. 2.5, 6.5, 9, 9, 4, 2.5, 6.5, 12, 11, 13. Yep, put 13 as a 3. Made my 13 and 3. So your R is 0.155. Now here's the problem. When we do it without the outlier. Alright? So when we get rid of this, it's going to change all of our regression coefficients. Alright? So watch what happens. Just look at the bottom. You get rid of 1, so that means that our new lowest one is not this anymore. So all our numbers are going to change. So instead of 35 being our lowest is going to be this one. So it's 1, 2, 3, 4, 5, 6, 7. See, I can't do this so close. 6, 7, 8, 9, 10, 11, 12. No, we're not using this. Now this one we get lucky. It changes all the way at 11, so it's good up to 11. So everything else before this is good, but 12 becomes 11 and 13 becomes 12. Because all the numbers before it changed. So when you type all them into your calculator, if you're pretty good at this stuff, when I hit my stat edit, I can keep everything until I get to 12. My old 12 becomes an 11. I delete my old 11. And then I put 12. And then I got 8, 4.5. Now your whole L2 column has got to change. But what you're doing is you're going down. So 1, 5, 4, 8, 6, 2, 3, 10, 11, 12, 7, 9. All right. So I got all my new numbers in here. Notice the 1 isn't being bothered right now. All right. I go to stat, calc, then reg. Boom. Jumps me up there. 0.76. Okay. So now you got it with and without the outlier. Notice without the outlier, our answer is a lot nicer. Still not fantastic, but still better. All right. Now, here's some more questions. We have our scatter diagram. Which correlation coefficient is more affected by the presence of the outlier? which one do you think was? It was actually, these are the differences between the two. It was RP. The Pearson had a difference of 0.487. The Spearmint only had a difference of 0.2 530, right? Describe the association. It's a moderate, positive, and it's a linear correlation. Right? The 0.64 makes it the moderate. And that is problem number 4. On to problem number 5. Alright. Problem number 5 says a clothing store recorded the length of time customers were in the store and the amount of money they spent. Alright. Each review set has about 7 problems. Alright, so we're almost done with the first review set. Just so you guys know. It's 7 and then the next one is 8. So find the mean of each variable. Once again, what we're going to have to do is we're going to have to type all these into our calculators. All right, so let's go. Let's start typing. I'm going to go right to my list. List edit. Actually, I'm going to clear my memory. All right, clear all entries, clear all lists. Stat edit. Go, start typing. 8. Oh, I put it in the wrong side. 8. 18. 5. 10. 17, 11, 2, 13, 18, 4, 11, 20, 23, 22, 17. Ooh, that's 15. 0, 46, 72, 86, 0, 59, 33, 0, 0, 122, 90, 137, 93. All right. I got all my little guys plugged in here, right? To find the mean, once again, you're going to hit stat, the stat button right here. You're going to go over to calc. You're going to go to one variable statistics, number 1. You're going to hit enter. We're going to do it for L1 first. Those are our x's. Down to calculate, it gives you something like this. So it gives you the mean time would be your x with a little line over it is our mean. All right, remember the other one is our standard deviation. So we care about our mean, which is our average, which is 3.2666. Okay, now the mean is, you could do this without using the calculator. If you want, you can just add up all the numbers and divide them by 15. So if you added them all together, you get 199 divided by 15 is 13.3 minutes. Either way gets you the answer. I personally prefer using a calculator. If you could be my guest and add all these together. Because we're going to have to type them in our calculator anyway to find our regression relationship. Mean spending. Okay, so now mean spending, in case you want to do that with your calculator. If you want, you can add up all the numbers and divide by 15 again. Or you can go back to stat, calc. Now, when you go to one variable statistics, I don't want L1 anymore. I want L2. Remember, you're going to hit the second button, and then you're going to hit button number 2, because the 2 is your L2. And what that does is it changes L1 to L2 right here. Calculate, enter, and notice it is 57 and 0.1. Right? Or, old-fashioned way, add all the numbers, get 856 divided by 15, and you get 57.07. I said 0.1, I should have said 07 because it's money. All right? Draw a scatter diagram. You can draw it. Put all the points down there. So you put all the points down there. It says plot the mean point. The mean point is 13.3 over 57.07 up. Best fit I, remember that graph? That graph has to go through the mean point, right? and you want it to get as many points pretty much above as you have below. So that's approximately what our line looks like. What is the relationship we have right here? Anyone be able to tell me the relationship? Very simple relationship. The more moderate, positive, and it is linear. Pretty much what it says is, the more time customers are in the store, the more money they spend. Right? Because they're probably more interested in the stuff. Right. Problem number 6. Tomatoes are sprayed with a pesticide fertilizer mix. The table shows the yield of tomatoes per bush for various spray concentrations. Determine the value of R. And are there any outliers affecting the correlation? All right, so 6 is a pretty longer, a little bit of a longer problem. There's actually each thing. So, first thing, you're going to draw a scatter diagram. All right, scatter diagram should be drawn. 3, 67, blah, blah. Okay, so we got a nice scatter diagram now. It's all nice except for that. Because as you can see, I have a nice strong line right here. And then I just got U. So, we're going to go into our stat edit. We're going to make our list. 3, 5, 6, 8, 9, 11, and 15. 67, 90, 103, 120, 124, 150, and 82. Come on, zoom in, buddy. Boom. That's my list. We want a value of R. Give me that Pearson moment. Oh, look at that. I still have L2s from before. Make sure I change that back to second 1 to an L1. I always forget to do that. You'll know it because your R will be either 1 or -1 every single time. All right, so our R here is 0.3395. Ooh, that's disgusting. So we have a disgusto R. All right, 0.340. I don't like that R. But is there an outlier present affecting the correlation? One outlier will tank your R. So where's our outlier at? Yes, right now it's very weak, it's positive, and it's linear. However, there is an outlier. Where's our outlier at? So what can we do with that outlier? See an outlier, we're going to get rid of it. So at 1582, we're going to say, you're useless. We're going to get rid of you. We're going to delete you from our calculator. So, the outlier was found to be a recording error. So they messed up. It wasn't an actual recording thing from the data set. So we're going to recalculate R by deleting that. So, we still have our page on from before. We didn't touch anything. We're not going to go crazy. We're going to stat edit. We're just going to edit our list. And we're going to delete the 15 and the 82. So delete the 82. Delete the 15, and then I'm going to go to Stat, Calc. I'm going to recalculate my linear regression line. And then I get it right here. And now look what R is. It went from that crummy 0.34 to 0.9942. That's what I'm talking about, right? Get that good R. All right, so our R now is 0.994. That's awesome. Is it reasonable now to put a linear model there? Of course it is. It's now reasonable to draw it. Before it wasn't because it was such a weak correlation. It made no sense. Determine the equation. Oh, look at this. It's right on my calculator. Let's go back. Up. So I go back. All right. A goes next to X. So it's Y equals 9.93X plus 39.5. I use my A and my B. So using the calculator that we already did, Y equals 9.93X. We go to 3 significant figures plus 39.5. State and interpret. What is the gradient? Based on this, your gradient is your slope, 9.93. All right? That means for every additional milliliter per liter of spray, the yield of tomatoes increases by 9.98 bushels. Okay? So every little bit of milliliter per liter spray they use, they get an extra about 10 bushels of tomatoes. What is the y-intercept? 39.5. What does that mean? That means if the tomato bushes are not sprayed, the average yield per bush will just be 40. So you pretty much have 40 tomatoes per bush, but the more you spray it, the more tomatoes each bush gets. Okay? They'll get 40 no matter what, but then you start spraying it with stuff, and then you get a lot more tomatoes per bush. All right? Statistical analysis, right there. Ready for number 7? Number 7. Oh, not yet. Number 6 though. Use our line. Our line is y equals 9.93x plus 39.5. What is the yield of spray? If the yield of spray is 7 milliliters per liter, and you spray the tomato bushes, how many tomatoes should there be on a bush? You're going to plug something in here. So this is our x. So this gets plugged into our x. And as an answer, correct. You should get 69 and 51 hundredths plus 39 and 5 tenths. And you get about approximately 109 tomatoes per bush. It's a lot better than the 40. Spray concentration. If it yields, the yield is 200 per bush. I want 200 tomatoes per bush. How much concentrate do I have to put in the spray? So now our y is 200. You're going to subtract 39 and a half from both sides. You're going to divide by 9 and 93 hundredths. Okay? You have 16 and 2/10 milliliters per liter. Right? All good. That's a lot. Comment of the reliability. One of these estimates is reliable. One of them is not. Which one is? All right. If you said reliable in G, 1I, that's 1, is the reliable because it's an interpolation. The 109 and the 7 falls within these values. The 109 falls within the graph of values that we create our regression line from. So it is likely to be reasonable. What about this one? 200. Does 200 fall in this category? No, it's an extrapolation. So this 200 is actually outside where we have our data, where we collected our data from. So therefore, it may not be reliable. It could, but we're not sure because we only really concentrate on the information from the two poles. North, remember the high pole, the low pole? So between those two numbers, the lowest number and the highest number, those are the numbers that we're going to concentrate between 63 and like 150, 67, 150. Right? Because we don't know, something could happen after a while and it could change all our data. Ready for the last question? I'm feeling good. I feel like a hammer in this today. Number 7, the ages and heights of the playground are given. All right? Those are the children. So you have children ages 3 to 13. Their heights go from 94 centimeters. 94 centimeters is, nope, it's 94 centimeters. I don't got it. Oh, there we go. 94 centimeters is big. 94 centimeters is like from here to here. It's like this is 94 centimeters. It's pretty small. So I can like pick them up and carry them around like this. So about from 94 centimeters, so a little bit bigger than a yardstick, to, I don't know why I'm so off topic, to about 160. You know why I'm off topic? Because you should be drawing the scatter plot right there. That's why. All right? You drew the scatter plot. Guess what? I see some type of linear correlation there. That is awesome. All right. Oh, we're going to have to use technology to find the regression line. Could be worse. I could make you use the actual formula. So get your calculators out. Stat edit. 3, 9, 7, 4, 4, 12, 8, 6, 5, 10, 13. Whew. Took out that first column. See that? See how easy and quick you can do these? Without a calculator, you're in trouble. 94, 132, 123, 102, 109, 150, 127, 110, 115, 145, and 157. And I'm doing this all real time with you guys, just to show you that it's not very difficult to do. I didn't have to do this. I could have just took pictures of the stuff like I do in the next couple lessons and give you the answers to save time. All right, so I got this, stat, calc, for linreg, enter L1, L2, good, that's all right. What do we got? 0.98285 That's a good one. So, our regression line is very, very strong. Oh wait, regression line, sorry. I was giving you the R. My bad. Regression line, 5.98 x plus 79.96 or 70 or 80.0. Okay, state and interpret the gradient. The gradient is, once again, the slope, 0.58. Interpret it. What does that mean? What does it mean? Well, what it means is, every year, the child grows taller by an average of about 6 centimeters. Right? That's what it means. That's the gradient. It means they start at about 80 centimeters in this line, in just this thing. So obviously, if you're 0 years old when you're first born, you're not 80 centimeters. So that's why you really want to just deal with the interpolation. All right, so use the regression line to predict the height of a 5-year-old child. Based on the data, what age would you predict them to reach 140 centimeters in height? So do these two problems. All right, let's go check it out. 5.98 times 5, because that's your x, plus 80. 29 9/10 plus 80 is approximately 110 centimeters. That makes sense? Let's look. 102, 4 years old, 102, 109, 5, 150. That makes sense. About right. Based on the given data, what age would you expect them to reach 140 centimeters in height? All right. 140 is approximately 5.98x plus 80. Subtract the 80 from both sides. Divide by 5 and 98 hundredths. Approximately 10 years old. Let's see, 140, 10. That's about right. Looks pretty good. And both answers there are interpolations. They both fall within the data set. Okay, 5 falls between 3 and 13. 140 falls in between 94 and 150. All right, 157, sorry. So it does make sense. Hopefully it makes sense to you as well. All right, that concludes review set A. Breather. Here we go with review set B. 8 problems. For each pair of variables, discuss whether the correlation between the variables is likely to be positive or negative, and whether a causal relationship exists between the variables. So the first couple are easy questions. You should get these no problem. Right? It is a negative correlation. Why? Because as the price increases, the number of tickets sold is likely to decrease, right? When you raise the ticket price, less people are likely to buy it. It is indeed a causal relationship because the price is directly, the number sold is directly influenced on the price. Right? Less people will be able to afford tickets as the prices do increase. Right? Ice cream sales and number of shark attacks. What do you think? What kind of correlation is that? That's a positive correlation. You know why? As ice cream sales increase, the number of shark attacks is likely to increase. Do you know why? It's not causal. Casual? Casual, not casual. Causation, causal. I think it's causal. Why are they likely to increase? Why do you think that? Well, it's very simple. Both of these variables are dependent on the time of the year. Okay? Shark attacks likely happen in the summer. Ice cream sales usually increase around the summer. Also, more people buy more ice cream. More people around get eaten by sharks or attacked by sharks. It's pushing it a little bit. I understand. But you can see, you can make the threads. You want to go back more to the numbers, I know you guys. All right, match each scatter diagram with the correct rank coefficient. So go do some matching. All right, give me another minute. Here we go. So, pretty much how this works is, you have some numbers here. This one right here looks like this, right? That's that graph. This graph is pretty much like this. This one, something like this. So right away, the negative, C is going to be big. B, or it's likely to be 1 because most of the stuff's on the line. And this one, even though the graph is like this, what's happening here is, the reason it's about 7 is, if I did like something like this, you can see that you're pretty much going up and over, up and over, up and over, but it is a little bit like crookedish. So A, I put the lines on, is most likely to be C, because it's like a moderate, strong, like kind of on the borderline. B, that's what? That one's definitely very strong, if not perfect, so that's A. You've got a little outlier out here, but besides that, you're fine. And B, I already had the lines there, is the only one that's negative, and it is definitely a weak correlation, so that is B. All right. Next one. Three. Group of students preparing results for a mathematics test and an art project. The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. Construct a scatter diagram. Alright, so I'm going to make your scatter diagram. I like these because I already made these. It took me a while to make it on the computer, so I don't have to do it in the class. Boom! That's what your scatter diagram should look like. Importance of a scatter diagram, once again, to see if there's a linear relationship, to see if there's actually any relationship. Once again, okay, describe the relationship right here. Well, it's a negative. It's pretty strong, right? Strong negative, and it is linear. How do I know? Well, look. Whoop. Like this. Right? That's pretty good. Calculate the correlation coefficient between variables. Stat edit. Got a lot of stuff in here from the last problem, so I'm going to go to memory 4, clear all lists. Once again, stat edit. I'm going to type in my stuff. 64, 67, 69, 70, 73, 74, 77, 82, 84, and 17. Whew, breathe. 85, 82, 80, 82, 72, 71, 70, 71, 62, and 33. Got all my stuff typed in here. Hit my zoom. There we go. All right, once again, in case you guys forgot, stat, calc, lin reg, enter, 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 enter. The correlation coefficient is 0.6836. Ooh, interesting. Why do I say interesting? I don't know. Because I like the word. Why aren't you zooming? There we go. So, wait a second. Negative 0.9370. That looks a lot better than what I have. I must have messed up a number in my thing. So 477, 82, 84, 17. Ah, no way this is a 17. That makes no sense. Alright, so let me see how I mess this up. Always messing up charts. This is how I really mess things up. 84, 85, 66. Wow. 85, 66. Yeah, that made absolutely no sense the way that was. Alright, so I'm going to go fix my last line. 85, 66. Luckily I can just write right over it. Stat, calc. That's embarrassing. Calculate. No, my R is, there we go, negative 0.92961. There we go. It's always better when I didn't really make the mistake. I made the mistake transferring. I have to switch this on the paper too. Right? So that is the correlation between the stuff. Whoop. B. The last one is 85 and 66. I checked this too, that's the sad part. Alright, that was it. That was your answer though. Alright, ready for number 4? We're actually flying with the second one. 4, 5, 6, 7, 8. 5 more. Safety authorities advise drivers to travel 3 seconds behind the car in front of them. This gives the driver a greater chance of avoiding any type of collision, and the car in front has to brake quickly and or itself is involved in an accident. I try to do it from memory, not read it. My bad. A test was carried out to find out how long it would take a driver to bring a car to rest from the time a red light was flashed. The following results were recorded for a particular driver in the same car under the same conditions. That was a lot to write and type. Find the mean point. So to find the mean point, you can add all these numbers, and you can divide by the number there is, add all these numbers, divide by the number there is, or you can use the calculator. I will let you choose which way you want to do it. I'm going to do it in the calculator, just because I'm going to show you how to do it both ways. So you can add up all the numbers and divide by the total number, if you'd like. Start edit. I'm going to see what's quicker. I'm going to do it this way, and then we'll race if you do it the other way, and we'll see who wins. 10, 20, 30, 40, 50, 60, 70, 80, 90. You're going to beat me. 1.23, 1.54, 1.88, 2.2, 2.52, 2.83, 3.15, 3.45, 3.83. I don't know. Alright, so if you did it the long way and the way that I did it originally, I added up all the numbers on top, got 450 divided by 9. All the numbers on bottom got 226.3 divided by 9. And I got 5025.1 as my mean point. Calculator way. Type in both things into your calculator. Alright, once again, whichever you would rather do. Stat calc. One variable statistics. List x1. That gives you my x. My x is 50. All right. Back here, stat, calc. One variable statistics. Turn this to an L2 by hitting the second button. Hit the number 2 button. Watch L1 goes to L2. Calculate. 2.51. Wait a second. Yeah, 2.51. That says 25.1. 2.51. My bad. Oh, what did I do here? Decimal place in the wrong place. All right. So it's 2.51. Good thing I did do this one. Simple little decimal place. All right. So draw a scatter diagram for the data. Draw a scatter diagram for the data. You're drawing your scatter diagram. All right, I'm putting my mean point. It's over 50 up 2.51. So it's right there. All right. Best fit line. Okay, let me see. As long as I'm including this mean point, I go over and let me go down here. I go, okay, let me tilt this, about that. That looks about good. And there we go. It almost includes every single line. I'm sure this R is very, very high, if not perfect. Oh, we're going to find it. Are we going to find it? No. All right. Then we'll go with this one. Not done with the problem yet. Find the stopping time for that speed. We're going to use our graph to find the stopping time. All right, very easy to do to use the graph. You can always just create the equation and use that as well. But let me go 55 this is 40, 50. Wait. You do it. Pause, unpause, you did it. Between 50 and 60 is 55. I'm going to run that up to the graph. I'm going to run that horizontally, and I get about 2.7. All right. What about 110? 20, 40, 60, 80, 100. 110. Run it up. Run it over. About 4.4 seconds. Comment on the reliability. One of these estimates is pretty reliable. The other one is rubbish. Which is which? Well, C is an interpolation. It falls inside our data set. Okay, so anything that falls in here, right? This piece of the line is the good piece. That's the one that we can make some interpolations for. That's the one where we can make predictions. 4.4 is likely to be reliable. C2 is an extrapolation. It falls outside this area. Extrapolation. Therefore, it may not be reliable. Can it be reliable? Of course it could. But we don't know. And we're not going to take that chance, especially when dealing with statistical analysis. All right? Good. Phone didn't die yet. Number 5. We got 5, 6, 7. 3 more. A craft shop sells canvases in a variety of sizes. Table below shows the area and price of each canvas type. Construct a scatter diagram of the data. You got it? Make your scatter diagram. Go. Make it. All right, you made it? There you go. Very big graph for not many points, isn't it? All right, so I made this scatter diagram. I'm going to calculate the product movement coefficient. Second mem. I'm going to clear all my lists. Sorry, I'm starting to hit a wall right now. Step, edit. 100, 225, 300, 625, 850, and 900. We got 6, 12, 13, 24, 30, and 35. Bam. Find the coefficient, stat, calc, and reg. Uh-oh, got two L2s here. Second one, turn that back into an L1. There we go, 0.99421. Describe. Wait a second. 0.994221. Yep, that's right. Describe the relationship between area and price. What happens? It is very strong, almost perfect. Positive because it's going up. Right? This is the graph right here. This is what the line looks like. Notice almost all the points are touching my line. Linear correlation, yes. There you go. Find the regression line and draw it on your scatter diagram. So, I saved this, it didn't touch anything. Way to find the regression line is look at y equals ax plus b. Oop, that's shaking. There we go. So it's y equals 0.0335x plus 3.27 ax plus b. Okay, go to three significant figures in both cases. All right, way to draw this is our y-intercept is pretty much 3.27. This is 5, so 3.27 is about right here. All right, and then you're going very small ups. So if I go up 10, I'm going over, actually let me just pick, I just pick like a number. I'll pick like 400. Put 400 in here, I get like 430. Sorry, I get 15. You just type in your numbers and then pick a couple points and draw a line. All right. Estimate the price when the area is 1,200 centimeters. So the area is your x. That's what you can type in right here. That's your independent variable. 0.335. This is 335 10,000ths times 500. 1,200 plus 327 10 hundredths. 40.2 times that, and that gives you about 43.47 pounds. Right. Is it likely to be reliable? Not really. It's an extrapolation, therefore it's unreliable. 1,200 actually is over here, and our graph is really only reliable up to about 900. Okay. 900 square centimeters. Problem 6. 8 identical flower beds contain petunias. The different beds were watered a different number of times per week, and the number of flowers a bed were produced is recorded in the table below. Right. Draw a scatter diagram for the data and describe the correlation between the variables. So draw your scatter diagram. Oh, that's pretty nice. Looks like a pretty good one. How would you describe that? Used your words. You would say that is a very strong. And this is about to get an R. Look at this. Very strong. Almost. Look at that. Almost all the points are touching my line. Very strong. It's going up. Therefore, it is a positive. And definitely, I would say a linear correlation. Find the equation of the regression line. Well, we've got to type some stuff into our calculator to give us the regression line. So I'm going to go second mem, clear all list, which is number 4. I'm going to go to stat edit. I'm going to go type in my stuff. 0, 1, 2, 3, 4, 5, 6, 7. That was an easy column. All right, let's do the next one. 18, 52, 86, 123, 158, 191. 228 and 250. Looking pretty good, right? Stat, calc, lin reg. Y equals 33.97, so 34.0x plus 19.3. Let me check out my answer. 34.0n. Okay, instead of using x here, we use n for the number of times, plus 19.3. Right, and it's F equals flowers produced. All right, plot it on the same line. So way you can plot it is point about 20. You're going up 34 over 1, or up like 3, 4. I'd like go up 70 over another 34. So up 34 over 1, up about 70 over 2. Is it likely that a causal relationship exists between the two variables? Explain your answer. What do you think? Times water, flowers produce. The answer is yes. Of course there is. Anyone that knows anything about flowers. Plants need water to grow. That's basic life, right? People need water to live. You stop feeding people water, giving people water, you'd have less people too. It is expected that the more water will result in the increase of flowers. So the more water that flowers get, or the more water that something gets, the more flowers are produced. That is an extremely causal relationship. Violet has 2 beds of petunias. She waters the beds 5 times a fortnight, the other 10 times a week. How many flowers can she expect each bed? Ready? First one, 5 times every fortnight. You know how long a fortnight is? Fortnight. Well, the formula we said before was 34.0n plus 19.3. 5 times a fortnight. A fortnight is 2 weeks. So that means she waters it 5 times every 2 weeks. So, 5 divided by 2 is 2.5 times a week, right? 5 times every 2 weeks, 5 divided by 2 is 2.5 times per week. Not much. Look at it. 34 times 2.5 plus 19.3. 85 plus 19 and 3/10. And it's about 104 flowers. 104.3. 104 flowers will be in that bed. So guess, 10 times a week, you think it's going to be more or less? And it's 10. Of course it's going to be more. 340 plus 19 is 359 flowers. Now, which one of these seems to be reasonable? Let's go backwards real quick. All right. One of them is not reasonable. Let's look at our graph. Our graph only goes up to about 7. So 10 weeks doesn't seem reasonable because it's going to be an extrapolation. All right. 2.5, that falls in our graph area though. So that one's going to be a reasonable. So EI, when 5, that's an interpolation. The 5 times every fortnight. So that's definitely likely to be reliable. The 10 times, that's an extrapolation. Okay? So that estimate may not be reliable. It may be reliable, but we're not exactly sure about it. All right? Got it? Awesome. All right. A driver. A drinks vendor varies the price of Superfizz on a daily basis. He records the number of sales of the drink as shown. Make your scatter diagram. All right. There's Scott. Ooh, are there any outliers? So we didn't type anything in the calculator yet, but are there any outliers here? Yes. Look at that guy. What is he doing up there? Should it be included? So 1.7, 597. That's weird. It should not be deleted. The reason this one should not be deleted, anyone know why? Even though it makes no sense, why should it be deleted? There's no evidence of a recording area. This is real data. Even if your data doesn't fit your graph perfectly and it looks like an outlier, if it's real data, if it's real recorded data that you actually took and didn't make a mistake doing, you have to keep it. Okay? Oops. So you have to keep this data. Calculate the equation of the regression line. Let's go. I gotta go back here to do it. So I'm gonna do it with you. Only 2 more graphs to type in. Second, mem. I'm gonna clear all my lists. And I kept on telling myself too I wasn't gonna type in all these lists. But I'm gonna do it with you guys. 2.5, 1.9. I'm leading by example. 1.6. Oops, I watched that movie Heroes, Who Could Be Heroes. Excellent, excellent movie though. 2.2, 1.4, 1.7, 1.85. Bam. 3, 8, 9, 450, and 448, and 386, and 381, and 458, 597, and 431. Calculate the equation of the regression line. I got all my stuff in there. I'm going to stat, calc. Negative 116.46, 664.5. What do you think? Is that what you got? Negative 116. Very good. Plus 665. Notice, 3 significant figures, so I didn't need decimals. State and interpret the gradient of the regression line. So which one of these is the gradient? Negative 116. Interpret it. What does that mean? Drink vendor varies by the price of Superfizz on a daily basis. He records the number of sales of the drink as shown. With every additional dollar the price increases by, the number of sales typically decrease by 116. That makes sense. Like, who would buy water in the front lobby for $1.50? I can't believe some of you guys did. But if they raised it to $2.50, I think even less people would buy the water. Do you think the regression line would give a reliable prediction of sales if it was priced at 50 cents? So 50 cents, let's see. Does that fall within a regression line? No, right? That's a what? Extrapolation. All right, the prediction will not be accurate. It's an extrapolation. It is too cheap. So you might all buy it up. If you guys ever went to, I think Costco has it. They charge like 25 cents or 50 cents for a bottle of water there. Just because they're not trying to really make a profit on it. But then you go to other places, they charge more. You might sell the same amount just because people can be more thirsty in the other places. All right, number 8. Hope that was a good explanation. Last one. And then we're going to chapter 5. Bird bath is filled with water. Over time, the water evaporates as shown in the table below. Draw our last standard diagram. All right. Whoa, that's not good. What do you think? How's that looking for you guys? That doesn't look very linear to me, does it? Oh, we're going to have to find Pearson's product movement correlation for this data. So, stat, edit. Let's go type some stuff in. 3, 6, 9, 12, 15, 18, 21, 24. All right, then we're going to do the next one, which is 6.7. It's 3.6. It's 2. It's 1.1. It's 0.6. It's 0.32. 0.18 and 0.10. All right, so you got all the stuff here. All right, everything. listed right on the calculator in here. All right, now we're going to calculate the R. You're going to hit the stat button, you're going to hit the calculate button, and you're going to go number 4 lin reg. Calculate. Now the regression looks like negative 0.874. All right, so that's a pretty decent one. However, it doesn't look like we're going to want to use that one too much. So if I go to RP, 0.874. All right, so we got that so far. Now what we're going to do is, we're going to do some ranking, because I saw that wasn't linear, so we're going to need to do our ranking again. When we rank our stuff, remember lowest to highest. The lowest number here is, I'll let you guys do it. All right, you done? 1, 2, 3, 4, 5, 6, 7, 8. They go up by 3, so it's in order. This one isn't exactly in order. The lowest number is the 10. 1, 2, 3, 4, 5, 6, 7, 8. It actually goes left, right to left. 0.1, 1800, 3200, 600, 1 in 100, 2, 3 in 100, tenths. 1 tenth, 6 tenths, 1 in a tenth, 2, 3 and 6 tenths, 6 and 7 tenths. All right, so that's our ranking. I want you guys now to take these plots and plot them. Plot 1, 8, 2, 7, 3, 6, 4, 5, 5, 4, 6, 3, 7, 2, and 8, 1. Now, I don't even really need to do this. I can do this in my head. I can tell you right now the answer to that is negative 1. If you don't believe it, and if you're not, you're a little scared, you can always just type this in one more time. All right, so I'm just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoop, there's only 8. You see how quick I did that? All right, I go to the second one. 8, 7, 6, 5, 4, 3, 2, 1. All right, I already had those in pretty much while you guys were staring at the screen, or I don't even know what you guys are doing. All right, so you get those in, stat, calc. We're gonna make sure this is negative 1. And guess what? It's negative 1. All right, 100% perfect correlation line. I like the way that looks. Which correlation line is more appropriate? Well, duh. It's obviously going to be the Spearman correlation line. From the scatter diagram, the relationship is clearly nonlinear. Remember before I told you it had like a quadratic or an exponential loop to it. Therefore, Spearman's rank correlation coefficient is much more appropriate. There. Right? Guess what? Done. Bivariate statistics, review sets. Had a nice review with you guys. Very happy we were able to do this. Hopefully you guys learned all this stuff and you're great with it. Notice I didn't really put any of the residuals on there. It's not a huge thing. It is important to do, but it's not a huge part of the lesson, so you don't have to worry about that. But the rest of the stuff, it all goes hand in hand. So now you should be able to actually understand and comprehend some statistical analysis. All right? And you should calculate and find all the stuff. So, good luck on your test then. I know you guys are doing great.